My name is Ken McDonald, and I'm a Principal Solutions Architect at Checkmarx. I'm going to walk through some of the automation capabilities with integration between common repository types such as BitBucket Server and Cloud, GitHub, and GitLab, as well as defect management systems such as Jira and GitLab Issue, GitHub Issue, and other defect tracking systems. The automation is not built within the context of the Checkmarx application yet, but we have a separate module that can integrate these systems together and create a closed loop automated pipeline to integrate any DevOps flow that you wish. So the first way to run this automation is by leveraging webhook functionality from the common repositories. From the repositories, you can register a webhook. You have our automation service listening for these webhooks, and it will orchestrate scans, create a project, kick off the scan, and then provide feedback either in line with a pull request, merge request, or providing closed loop tracking within defect management systems. The second way of running this automation is a simpler command line approach, which can leverage an existing pipeline that leverages checkmarks in the background, such as if you're working with the Jenkins plugin or the Bamboo plugin, or if you're just running the CLI, all you need to do is produce the XML file, and this XML file can be pulled in to this automation module, and again can publish findings to the defect management system of your choice, and again providing a closed loop approach, opening and closing tickets automatically. The two approaches to running this code or module comes from the same source. It's just executed in different ways. One is obviously a web service, and one just with a command line execution and completion. There is a third way to execute the module in a command line fashion, which is considered a batch mode. And in this approach, you simply provide the team and the project, and the latest results for that project will be retrieved, and the same flow will take place where it publishes findings to the defect management system. Additionally, you can point to an entire team, and you can iterate through all projects under that team, grab the latest results, and again publish findings. The third approach obviously is the entire instance of Checkmarx, where you go through all teams and all projects within the teams and publish findings. And the findings can be filtered down based on various categories. So you can filter out based on severity, the type of vulnerability, the CWE, and the status of the issue within Checkmarx. And the status being whether it's a new issue, a confirmed issue, an urgent issue, and of course the not exploitable, which is likely not the scenario you would cut a ticket for. All of the elements of the defect management as well as webhook orchestration can be overridden on a per repository basis or per organization or namespace level within a repository, or sorry, within a GitHub structure or GitLab structure. You can provide the filtering context on each command line execution, and you can just provide any override you can possibly think of in whatever context that you require. So there is a global default for each of the executions, but you can override as needed. So the override capabilities actually stem from a JSON-based blob that can be added in a base64 encoded fashion on the webhook registration, but I will not go into this in too much detail. I'll just show the base capabilities, but just understand that everything can be overridden as required, and all of these capabilities can be introduced in different forms and fashion into your DevOps pipeline. So I'm going to start off by showing a GitHub webhook workflow and how it can create a project and introduce the results in line within a pull request. You can see my Checkmarx instance here. It is not running any projects right now. It is not scanning. And here I have a GitHub repo, and I'm going to look at the settings and show that I've registered a webhook. This webhook has been registered to listen for both pull requests and push requests. The pull request workflow is slightly different than a push request. The pull request will actually provide results in line with a pull request or a merge. The actual invoking of scan will only take place if it's a pull request into a branch that's considered protected. And this is a configuration you can provide globally and on a per repository basis, where you say my protected branch is, for example, master, security. It can be a release branch. If anything matches the criteria before the merge takes place, this will kick off a scan and provide you the results that meet your filtering criteria in line so that you can make an educated decision before you merge the code into your protected branch. A push request will invoke a separate flow where it provides feedback to whatever bug tracking system you're using. In this scenario, I'm going to create a pull request and then merge the code, which will in turn invoke a push request, which we'll see both in action here. So I will first do an update to the code, and I'm going to simply do an inline edit and create a new branch, a hotfix branch, and do a pull request all through the web console. A real world scenario, you would be developing on your IDE, you would be checking out a hotfix branch and publishing, but for the sake of a demo timing, I am just going to edit inline, and it'll be a very simple change. So if I edit this file, a very simple edit, I will say please create a hotfix. And I will create a pull request for that change. Now my configuration is set such that master branch is a protected branch. So I have a service listening and it will kick off a checkmark scan automatically. So you can see here it's been provided in line. And if we go to our Checkmarx instance, you will see that a project's been automatically created for that hotfix. So as the scan's taking place, we can talk about the team management in the background. There is the concept of single tenant versus multi-tenant, in such that if you specify multi-tenant, it will create a team underneath your automation team structure for each organization, which is the organization of GitHub. This one in particular would be under Custodella and then riches-hotfix. So it would have created a team, if it didn't already exist, called Custodella, and then added the repos underneath or projects underneath. In a single tenant, it would provide the namespace or organization level in the name of the project. And to show this, you can see the branch view, the tree view for organizations. And you'll see under the automation tab, this organization or this team was created. Also, I'd like to point out that all of these capabilities for pull and merge integration will also exist in GitLab. And I'm just going to show here the webhook integration that's possible. And again, you can see that merge requests are set here. So this is only listening for merge requests. After the merge completes, it will actually invoke a Jenkins build deployment. So you can get your feedback in line with your merge request before you merge your code. And then once the code is merged, it will execute against your Jenkins pipeline. That's just a scenario that you can use for these capabilities. Similarly, BitBucket, you can register the webhook as well. Here it is. So you can see I have a webhook registered here. In the event you'd like to do rapid onboarding of any repositories being scanned and any branch being actively developed against, you can add a global or organizational level plugin. Webhook registration. So if I open a new tab under my organization, I can apply a global webhook. Applying a global webhook would allow for any repo underneath to be under the realm of this webhook registration. And any code being checked in to protected branches, pull or push, depending on the registration, you will have the automated flow kickoff. So here's our pull request. You can see that the issues have been brought back in line with the pull request. So I now can make an educated decision on if I want to merge this code into the protected branch. And likely, I would probably kick this back to the developers and say, please fix. A few changes that will be introduced in the future will be the ability to stop this button from allowing a merge request to take place if a certain threshold is met, as well as not being able to press this merge pull request button until the scan has completed. Again, this is a future implementation that's on the backlog. So I am going to ignore these security issues and merge the code so that I can show the push request integration, which will provide the feedback to Jira. I would like to point out a few things here. This is only a subset of the issues in which we care about from our program methodology perspective. So I've only filtered out things such that are high severity, but you could say only give me high cross-site scripting, and then you'll only receive those particular issues. In the event you want to click on one of these issues, it'll bring you directly to the line within your repository. If you have a single file and multiple references to a specific vulnerability type, it consolidates all of the various lines under one bucket. And I'll show this in the Jira workflow as well. As you can see, the master branch has kicked off and already finished, and that was due to the push request that we created after the merge had been successful. In the background, it will be creating these Jira tickets, which you can see the empty Jira dashboard here. And as I refresh the page, it will populate with the most recent Jira tickets. So after refreshing the page here, you can see now this simple application security dashboard has been published with our application's results. And these are very basic use cases to show the capability you can have by publishing your findings to Jira and to a specific application security bug type with common fields that you can extract for reporting and metrics. I'm going to dive into a couple of tickets just to show the content. So a few things to make note of is that any custom field and any custom workflow and transition is acceptable with this solution, and it's a matter of configuring everything properly. In this scenario, I have a custom field for line of code, and you can see that this particular reference or issue has 4 references within that file. The CWE number is also a custom field. Also, in the event the developers fix 2 of these issues, the next iteration, the ticket will be updated to reflect the remaining issues. So you'll still see 2 here, and below the details of the issues, you will also only see the 2 remaining issues. Once all issues are gone, the ticket will automatically close. In the event a developer reintroduces the vulnerability, the existing ticket will be reopened. So just walking through the content of the ticket, we try to provide as much as we can that's available. The description of the issue, some repository details. Under the additional information, you'll get a direct link to the first reference within Checkmarx in the event you want developers to log into Checkmarx and drill down into the results viewer. These optional fields that can be configured. You can provide a link to MITRE to allow for details on that type of vulnerability in the event developers need help. For CWE 889, they can get as much details from here as possible. In the event you have a training website or code bashing, you can provide a link embedded here as well. And most importantly, I would say, is an internal guidance or wiki that typically you help guide developers with fixing cross-site scripting and SQL injection, as opposed to letting them just go to the internet and Google the first result and apply their fixes. Again, if you go to the actual line here, it will bring you to the repository and the exact line. So I believe this is everything that I'd like to talk about with the ticket itself. Again, reiterating that it is closed loop. It will automatically reflect and close tickets and update existing references to line numbers every time the iteration takes place. Marking an issue as a false positive or not exploitable within Checkmarx will remove it from the result set. Another approach, as discussed earlier, is to leverage the existing XML output from a Jenkins plugin for Checkmarx, which I will show the breakdown of this particular job. Now, in this scenario, we're using the Jenkins plugin, and we are also enabling OSA scan, so for third-party vulnerabilities in libraries. And we are then executing this automation for ticket generation from both the SAST output, which will be an XML output, as well as the OSA output, which is based on 2 JSON files. So I will also start this scan, and we can see the results that will be produced, very similar to the webhook workflow. I'd also like to reiterate that this is a starting point. It can be easily extended. We can add different bug tracking and defect management systems. Adding an additional repository for webhook integrations such as TFS or VSTS is possible. In its current form, it is not available, but can be easily added. So while this is taking place, we will show that the scans are taking place on our Checkmarx server. It looks like it's finished, and it's now conducting the OSA scan. You can see that the automation has kicked off and has taken in the XML output and produced several results for both SAST and then again with OSA. Now, if we view the results, you can see that similar to the SAST results, multiple references to issues from a third party will be condensed into one ticket and again updated as the issues are removed and again closed when all have been removed. The command line execution also has the same formatting and output expectations as the webhook flow. And that is all I had to show. Thanks for watching.